Okay, we're looking at examples from 12.6. All right, example 1. In the figure, 0 is the center of the sphere and plane P intersects the sphere and circle R. If OR is 6 centimeters and OS is 14 centimeters, find RS. Okay, what we have is a triangle, and if you need me to show you this in class too as well, I could take, obviously, sometimes the visualization here is kind of tough. This is like taking my Play-Doh sphere and then taking a piece of paper and cutting right through it. And then you end up with this triangle here. So this is like along the piece of the paper. This is from the piece of the paper to the center, and this is a radius. Okay? Basically, I'm just going to fill in the information. OR is 6 centimeters. OS is 14, and now I need to figure what RS is. Well, guess what, folks? That Pythagorean theorem is going to come into play here. So I'm going to take a squared plus b squared equals 14 squared. Basically, it ends up, I got to take away 36 from this. I get 160. And the square root of 160 is 12.6491, which I am going to round to the nearest 10. I've got 12.6 for my value of b, which is my radius. Okay, example 2. Find the surface area of the sphere given a great circle with an area of approximately 907.9 square centimeters. So I've got a sphere, and I need to find the surface area. We know that's 4 pi r squared. The great circle, once again, if you take that Play-Doh, cut it in half, the part that touches the knife, or I use a piece of fishing line to cut that in half, that part that it touches is considered the circle, the great circle. So the area is pi r squared for that. And the great circle is 907.9. What I need to do is figure out what r is so I can put it back up in here. So, to solve for r, I'm going to divide both sides by pi. So 907.9 divided by pi gives me a value of 288.9935. And then I'm going to take the square root of that, and I'm getting r equal to 16.9998. And they do say this approximately thing in here. Not my favorite thing they do with a problem like this. So if you see that, I think you'd be okay with 17, but being that we're following the rules of not rounding till the very end, I'm going to rewrite it up here. So I have 4 pi, the radius is a 16.9998, and I'm going to square that. So let's do a little calculation. Times 4 pi, and I'm coming up with a surface area of 3,631.6. My label will have to be centimeters squared. 3,631.6 centimeters squared. All right, example 3. Find the surface area of a hemisphere. A hemisphere is when you take a sphere and you cut it in half, with a radius of 3.8 inches. We did talk about how we get the surface area of a hemisphere, and it's actually 3 pi r squared. Okay, the radius is 3.8, so I need to put 3.8 in for r, so I'll take 3 times pi times 3.8 squared to give me the surface area of that hemisphere. And basically, it's just a calculation. 3.8 squared. I always do that first when I do my calculations. Maybe you don't, but as long as you get it all in there. Our answer should be 136.09, which means I'm going to round to 0.1. And then my label should be inches squared. Okay. And example 4. Find the surface area of a ball with a circumference of 24 inches to determine approximately how much leather is needed to make the ball. All right, so I have a circumference of 24, and I need to find the surface area of the sphere, so 4 pi r squared. Now, somehow I have to turn that circumference into some information about the radius. So let's think back. You're in class, it might make you look this up or something. You can either use pi times diameter, or when you see the C, write the D, or 2 pi r. Sorry, let me rewrite that. 2 pi r. Okay, I'm going to use this equation because that's going to help me get the radius, which is what I need. So 24 is actually equal to 2 pi r. If I want to solve for r, I've got to undo the 2 pi, which means divide both sides by 2 pi. All right, watch your calculators here. If you just type in, this is what a lot of you are going to do, 24 divided by 2 pi, if that's the way it goes in your calculator, it will be wrong. Because what it's doing is taking 24, dividing it by 2, taking that answer times pi. Okay? So what we want to do is what's right. We are going to do 24 divide by, and then in parentheses put your 2 pi. Okay? So you have 24 divided by, and then put your parentheses, and everybody should be checking this on their calculator, making sure you're getting this right. And I'm going to get a 3.8197. This is how you do it correctly. Okay, so that's what we call right. And that's my, once again, radius. So I'm going to put that up in here. Okay, there are other ways, but be careful. This is a common thing that kids do, that students make the mistake, make the mistake of doing, and I don't want you to do that. Put those parentheses around that. All right, now that I have the 3.8197, now I'm just going to, they might be touchy, 4 pi, and then the radius, 3.8197. I'm going to square that, oops, square, to the second power, times 4 times pi, and I'm getting 183.3. And the label on this would have to be inches squared. Okay, that's example 4, and that ends our last example for lesson 12.6. And this is actually the last lesson for the entire chapter, for chapter 12. So, until chapter 13.